All right, let's look a little more into these translations here and get into multiple situations. So I'm going to start out by doing another example where we're just doing a translation. What we're talking about in translation is really just sliding it. Translation, okay, now we have a little more time, is when we're adding or subtracting. Okay, that's going to be one of the things that we look at. So again, how we want to start this is think about what's happening if I don't have any numbers multiplied or divided to get my paragraph, or my parent graph. So I'm dealing with y equals the square root of x. Okay, and so what I'm going to do then is go back to that parent graph sheet, and I'm going to copy down my table. I'm going to copy down my domain and my range. Okay, so that's the first thing. That's the reason for that parent graph note sheet, is that we want to be able to go and copy down that original as if nothing's been done to it. Now, then I'm going to get into describing my transformations. So that -1, again, it's inside. So it changes my x, and again, we want to talk about doing the opposite. So rather than a -1, which most of us would probably imagine x direction, that's the left, we're actually going to go to the right one. Okay. How that changes again my table is, since it's inside, since it changes my x, again, we do the opposite. So I'm going to add 1 to every one of my x values. And like I mentioned, cross off the ones that we aren't going to use anymore. Also do that to your domain, because that's what talks about your x's. So my new domain is x's are greater than or equal to 1. A +3, that's the y value. Okay, and again, that moves us vertically, and what that is, it's simply going to be up 3. Nice thing again is my y's do exactly what we ask them to do. Since they're adding 3, I'm going to go add 3 to everybody here, including my range again. Okay. And now it's as simple as going in and plotting 7 points. 1, 3, 2, 4, 5, 5, and a lot of times you're not going to get all of them to fit on there. The one that's very important to remember is going to be this point right here. I kind of consider that like a starting point, since it's not, with a quadratic, you have the parabola, so that's a change in direction at your vertex. You have that same situation with next cubed where you kind of change in direction. You don't have that here. So you kind of want to remember that point. It's kind of your start point. Okay. Similar to your vertex, and so now what I can do is I can graph that. Next thing I want to do is think about checking my domain and range. X is greater than or equal to 1. Well, here's x equals 1. Okay, yeah, x is greater than or equal to, I have a point on a graph. Where I can go the other direction, I don't. Okay, the y is greater than or equal to 3, same idea. We kind of want to think about it that way. All right, dilations, and these are going to be our stretches and shrinks and reflections. Stretch, shrink, reflect. And these are going to get caused by multiplication. Okay. So as you see in this first one, all I have is 3x squared. So it's a pretty simple situation. So again, I want to start out thinking about what's my parent graph. So if there were no numbers there multiplied or added, all I have left is y equals x squared. And again, go copy your table, copy domain and range. Now, there's the only number I'm dealing with here. It's a 3. If I go back to the parent thing, A, B, and 3, that is, again, just the number part. Okay, just my number part. My number part's greater than 1. I have a vertical stretch. Okay. So there's going to be one of those situations where we look at that rubber band, I'm going to pull it away. Okay, so now, outside changes y. And again, nice thing is we do exactly what they're doing on the outside. How do I know it's on the outside? I don't see any grouping symbols. I don't see any parentheses. I don't see any radicals. I don't see any absolute value. So I'm going to multiply everything here by 3. Okay. I'm going to multiply my y value, my domain, or my range, I'm sorry, by 3 as well. Well, it doesn't change it. Okay. Now, since I didn't do anything to my x's, my domain is not going to change. Okay, so if I go plot my points, negative 2, 12, it's going to be kind of hard to put on this one, but negative 1, 3, 0, 0, 1, 3, same idea. But again, you can see it's skinnier because your parent graph, remember, is out here. And so now, if I kind of sketch that in there, you can kind of see it looks like I pulled that rubber band up. Okay. So that's what happens with the stretch. Okay. So kind of quickly with this one, y equals x cubed to get my parent graph, get my table, okay. Copy my domain, copy my range. Nice thing is, if your domain and range is ever reals to start with, it's going to be reals at the end as well. Okay. All right, so describing my transformation. Now again, the negative has its own piece. The sign tells you what we're going to do with it. If it's a positive, nothing. But if it's a negative like we have here, it's going to be a reflection because it's on the outside, it's over the x-axis. The 1/2, okay, the 1/2, because that's less than 1 but greater than 0, that's causing us a vertical shrink. Okay. Now, the nice thing about the reflection and the shrink, I can deal with those at the same time. It's on the outside, so what I'm going to do is I'm going to multiply everything by negative 1/2. I can do both those at the same time. I don't have to deal with the negative and then the 1/2. Okay, so it becomes positive, these become negative. Change my y, so again what I should do is multiply this by negative 1/2 as well, but again that's still going to be all reals. Okay, now remember, x cubed goes like this. Okay, so now if I plot my new points, I should see it reflected, so I should see it flipped over. Okay, so negative 2, 4, negative 1, negative 1/2, 0, 0, 1, 1/2, and then 4. And so now you see the part that was pointing up before now is pointing down. All right, so now what we can do is start pulling all of this together and do both, a translation and a dilation. So again, cross off anything multiplied and divided, what's left, y equal x squared. There's your parent graph. Okay. Same process. Copy your table. Copy your domain and range. Start describing. Sometimes it's easiest just to go left to right. Okay, so this first two I run into. It's outside, vertical stretch. The negative 2. Inside, opposite, right 2. Up 3. Okay. Now, I'm going to start here because that's the only one that I have that involves the x. So again, opposite. So rather than minusing 2, what I'm going to do is add 2 to everybody. Now, the 2 on the outside, the vertical stretch, and the 3 both affect the y. How do I know which one to deal with first? Well, it's still follow your order of operations. Okay? Order of operations tell you to multiply before you add. So the first thing I'm going to do is multiply by 2. Then I can do my addition, subtraction. Then I'm going to add 3. Okay. All right, now same thing with my range. What I'm going to need to do is first multiply, didn't change it, and then add my 3. Like I said, if it's all reals to start with in my domain, it's going to stay all real. So we're good with that one. All right, so 0, 11, can't see it, that's fine. 1, 2, 3, 4, 5. Okay, 2, 3, 3, 5. So again, now I can see the parabola shape. I can see that with my range, okay, my y's are greater than 3. Okay, and so we should be good. All right, so good luck with all this.